Welcome to Conversations with Creative Minds. We have been searching for the meaning of creativity and the role it plays in our daily life. People use creativity to express themselves in different ways, such as writing, painting, poetry, composing music, or innovating new products. Creative minds have never been more relevant than today because of the need to solve our society's dynamic and complex problems. In this episode, we're honored to interview a remarkable man who has contributed significantly, not just to the space industry, but also to many other areas of our lives. At the time of President Kennedy's 1962 moon speech, much of the knowledge and tools needed to fly humans 250,000 miles to the moon, land on the right spot on the lunar surface, and return them safely to Earth didn't exist. NASA carefully selected a few thousand people, including the young Egyptian geologist, Dr. FaroukEl-Baz. Dr. El-Baz was responsible for studying the geology of the moon, the selection of landing sites for the Apollo missions, and visually training aeronautical engineers and test pilots using maps and images. Throughout his career, Dr. El-Baz pioneered different techniques, from visualizing the geology training courses for the Apollo program, testing GPS prototype systems, introducing the IMAX camera to NASA, and helped with the discovery of subsurface fresh water in the deserts of the Middle East. Dr. El-Baz's contributions to the space industry have been recognized in other ways, including naming the first shuttle pod, el-baz, for the Star Trek The Next Generation TV show in the 1988-1989 season.
Creativity is essential to the success of any individual or any group. And why is that? Because you need to do something above and beyond what an animal that was designed to make something, or a machine that was designed to make something, would do it correctly every time, exactly the same thing. Because we're human, we have thoughts and we can create. Our mind can create. Therefore, creativity is essential to something doing above and beyond, or something new, or something different, or some other approach, or some way of doing things that was not common in the past, or before you arrive on the scene. For example, when I joined NASA and I had no training in neither astronomy, nor lunar science, nor what Apollo was going to do. I was a geologist and I was an expert on mining geology, economic geology, mines, meaning my expertise was under the ground of the Earth. And there are some people talking about features and landforms on the moon. Therefore, I have a minus to start with. I do not know what other geologists that have been working at this for years. And therefore, if I am not creative, if I cannot give these groups of geologists something new or something more than what they have or they expect, I'm doomed. Why would they even look at me? Why would they even speak to me? I came looking different and they have an accent and they know nothing about me. So if I do not add to their knowledge, then I will be useless. And no one will ever hear of me. So how do I add to their knowledge? Well, the only way to do that is to be creative, to try to see what is it that they know, what is it that they are missing, and what is it that you can add to it. That's creation. so that you can figure out, oh, all right, these people say this and this and that, and what haven't they thought about? What is it that they don't know yet that you can emphasize in the group so that they can begin to think of you? And if you want me to give you the example, I would. Just being forceful, being completely aware of yourself, and knowing that you really can do it. Because I needed the job, there was no question about it. I arrived in America with absolutely no job and no nothing, and I had my wife and 2 kids, and no job and no money and nothing, and I knew no one. So I was absolutely a lost chap with the responsibility for 4 people. So this was a huge push to do something, whatever it might be, so that I can support myself and my wife and my children. So this was the biggest, which means that I will have to be able to convince anybody that I am the man for the job, and any job for that matter. I did not say I'm going to go in there to train astronauts. No way. I was there to do whatever the hell they wanted me to do. And I didn't even know that geologists will be able to talk to astronauts, not to mention training them, because all of that I developed. So there was no such thing in the process. This was 2.5 years before the Apollo 11 mission. So there was no plan for a geologist to really be part of the team, or for an astronaut like myself to teach astronauts. Teach them what? These are pilots. What do you mean? What can you teach them? These are pilots. They know how to do the job. If you want them to pick up a rock, okay, we will give them something to hold the rock and bring in some rocks. So that was the perception. And therefore, first of all, I had to be reasonable, or a little bit more than reasonable, actually. I had to be distinguished amongst my own fellow geologists. Because when I arrived, NASA had 65 geologists hired from the U.S. Geological Survey, paid by NASA, in a center called Astrogeology Division in Flagstaff, Arizona. And these are 65 geologists that have been working on the moon for at least 3 to 4 years before I arrived. So they knew tons more than I did. So my approach was not with NASA, was really with my fellow geologists. I thought I would have to be knowledgeable enough to speak to my geologist colleagues so I can communicate with them, so I can learn from them, and so I can add, if I can add something, I will add it, but they have to be good enough for them to talk to me. So that's the approach. So that I wanted to be good enough for my colleagues, the other geologists, so that they would talk to me. So I found out what have they been doing. I just found out that there are something like 2,000 images of the moon, and people are looking at it. And I said, fine, before I can talk to them, I should look at these pictures myself. And they sat down for 4 months. Actually, it turned out to be in total it was almost 6 months, from March to September, when the first meeting of this group of people, geologists, that are going to communicate their needs to NASA. And I thought, through my understanding of these features of the moon, which I looked at and decided what features I were. And because they are different from the Earth's features, I named them whatever it is, but they are structures and very different, and I grouped, and then they said, for geologists to really learn about the moon, we have to visit as many of the features of the moon as possible, so to get as many of the different types of rocks or materials on the moon as you possibly can. Very much like if you go down in the mine, so you look and you get samples, so make absolutely certain that you have a sample from everything so that you can figure out what is in there. in the final analysis and what's important and what's valuable or what can be best. So I did. And I sat down from the base based on my notes of the 2,000 some pictures on myself studying them. I thought that there are 16 places on the surface of the moon. If we go to all of them, we would have visited every kind of feature on the surface of the moon, which means most likely that we would have gotten samples from every kind of rock on the moon, meaning that the different features may have different rocks might form different features. So if we visit every kind of feature, we most likely would have sampled all kinds of compositions of lunar rocks. And that was it. That got me into my colleagues because they never thought of this approach at all. They were studying in detail features, and they go on and crater Copernicus and study it, and these hills and this, that. Every one of them became an expert on a kind of feature, but they're still unrelated, and they had no specific sites or nothing to say, how do we select sites? So the Lunar Landing Selection Committee, which was formed by NASA people, some professors from outside, and the geologist from this group of Flagstaff, Arizona, and myself, got down to talk about the potential of landing sites of the moon, and we're going to discuss each mission singularly and so on. And both based on our recommendation, NASA headquarters, the engineers, would approve the selection of the sites that we select, because it was called the Group for Lunar Exploration Planning. Within that group, there was Lunar Landing Selection Committee, and a committee to select landing sites on the moon. And that group of 28 people elected me to be the secretary of that committee, because I knew what features were and where they might be and what composition they might tell us. And I was able to convince my fellow geologists, and the fellow geologists thought that I would be able to convince the NASA engineers. I'd be able to talk to them easily. And that was it. So I became the secretary of the committee that selected landing sites on the moon. And I was the one to communicate the recommendation of the scientific community in total, from NASA, from outside, and from the group of lunar exploration planning, to NASA headquarters for this is the site that we want Apollo 13 or Apollo 14 or Apollo, whatever it is, selected for. This is a very good point, Michael. It's an essential point, actually. Whatever field that we'll be talking about, the point that you make is an essential one, very important. What is it that you're going to be looking at, and what is it that you can contribute? All astronauts were pilots, and they competed with the ability to move, to play, to turn the spacecraft around, to do this and that, and to pick up the landing site and land exactly on the spot. So that's the competition. So that's great. Fine, that's competing this. Then their teachers of science and geology specifically try to take them into the classroom and show them through the telescope the different patterns of different rocks. And they told them that this is basalt and this is the crystals within the basalt, this and that. And if you look in the microscope to do this and that. And these astronauts said, what the hell? I'm not going to have a goddamn microscope on the moon. I'm not going to select a composition or an ACL or something called such and such. None of these goddamn things are going to matter to me. Tell me I'm going to get some rocks, I'll get you some goddamn rocks. But that's it. I'm not going to be able to select the kind or whatever. Forget it. One of them told me, I don't want to touch a geologist with a 10-foot pole, meaning get the hell out of my way. So it was to approach them, you have to do a completely different approach so that you can allow them to contribute in the field that you're concerned about. You have to take a completely different approach. So what I tried to do was to say, I'm going to show you features on the surface of the moon the way you see them from orbit, meaning from a huge distance, and then recognize patterns so that when you look for landmarks on the moon, they use landmarks on the moon so that they can fix the orbit of the spacecraft. And the NASA Houston people used to give astronauts 5 up to 7 places on the moon and tell them this is first with this one and that one. And if several orbits they can see through the microscope, through the telescope. They have a telescope. They look at it and to enlarge the view. And then if they pick that crater and say, mark, then the Houston people would mark the orbit of, they know where they are, how high they are, and they mark that one, so they will know exactly where the orbit is, because we never were able to really fix or put the spacecraft in a specific place in orbit, and that turned out to be exactly the same, because of the gravity of the moon is different, and the way they moved into orbit was different, and the way the length of the burn of the spacecraft on the far side of the moon to get to the section is always different in every mission. So there are always little changes, and the NASA Houston had never really been exactly certain on where they are exactly. So to help NASA Houston know where the spacecraft is exactly, they asked the astronauts to look through this telescope and try to see features that they will tell them about beforehand. So if they can put it and put the crosshair on that feature and say mark, they can fix that one and then mark. And then next, as long as the orbit moves on like that, if they can get at least 3, hopefully 5 locations, then they would know the orbit exactly. So they usually give them 7 so that they can hope that they get 3 or 4 of them so they can figure out the orbit nearby. There was no way, there was nobody to tell them how do they get to see this orbit, to prepare for seeing these landmarks. And that's how I approached it. Of the geology of the moon, I said, I'm going to brief you on locating the landmarks. I didn't say a single thing about lunar features or geology or craters or nothing. I said, I'm going to help you locate landmarks. The 7 landmarks that the guys in Houston will give you, I will help you figure them out and actually compete with each other to see who can get this more of the landmarks than the other guys. Well, how do you do that? So I went out to take the location of the landmarks and show them the features before they get to the landmark, because by the time they are the sextant, the enlarger is right on top of the landmark, it's over. That's where we don't know where they are. So they either see it or not see it. They will see it if the orbit is exactly right, and not see it if the orbit is just off by a tiny measure. And in most cases, they do not see. So I thought, if they can look before they get to the landmark and figure out features that as they move around, they can figure out some of the features, can become familiar with the shape of the craters until they get to the point, so they know where that point is relative to these features before they look into the thing that they will have a potential of doing. So you think of it and tell them, okay, look as if you're looking through the sextant and look at this side. Then landmark 1. What do you see there that you can lead you to the place before you get right on top of it? And the guy would look at it and say, look at that, this crater, look at doublet. I said, the doublet, exactly. Well, and write doublet in ink, and that becomes the word for that feature, because there are 2 craters on top of each other like that, so we call it doublet. So fine with me. Let's call it doublet and change all the names on the maps to make this doublet. So they will call it doublet, and he knows that's doublet, and it is the landmark that he needs is just off the top of the left side of the one on the doublet on the right on top. That's it. He remembered that. Finished. The other one, they will see such and such and say, hey, look at it, look at the pattern of this line. The craters, it looks like a snowman. I write snowman. And as far as I'm concerned, that snowman becomes the name of the whole goddamn thing. It doesn't matter what the name is to the geologist. Never mind. This shape of a whole bunch of craters on top of each other is now snowman, and I write it down, and that becomes a name that I actually write on the maps they will take with them. Snowman beforehand, but there's the doublet, and that's a snowman. That's it. They go up in the spacecraft, and they see these things, and they pick them one after the other, and they fix them, mark the orbit exactly, and from there on, that's every time I go and talk to them about anything, they delighted, because whatever I taught them allowed them to fix the orbit of the spacecraft better than any of the other guys. And that became part of the competition. If they listen to goddamn Farouk or the king, then we're better off. So get that guy. I need some training, and they actually approached me while they're rejecting the geology training. The guys approached me. I remember Stu Rusa, Apollo 14 command module writer, came to me. He said, I was entering the astronaut office, and he said, hey, are you FaroukEl-Baz? I said, yes. I'm not going to correct his pronunciation of my name. And he said, listen, I'm going to be the CMP for Apollo 14. I want you to brief me the way you brief Ken. Kinematically, Apollo 13. Hell no. I want you to make me better than Ken. When can we start the orbital training? So they heard about it, and he went, and he wanted more, and he was delighted to see me and to tell me, hey, I want you to come and train me the way you trained that guy, because he has seen the other guy learning better than the other astronauts. And that's how we get them. Not by talking about the geology or the Copernicus or the rays and the geological features and whatnot, and what is aged, what is younger, and what is older, and why. But tell them something that will help them in their own work. To do his job better than the other guy, because they're competitors. So when they see that you're talking to him would make him better than the other guy, there is no other entry card better than that. I wouldn't really call it leadership at all. I mean, I don't think of it as I was leading something or leading this or leading that. I am a person that works out for the good of the group. I concern myself with the best potential for all geologists. I'm not going there to say, well, how do we make a name for FaroukEl-Baz? Not at all. How do I work such that geology gets a great place in the system, and how do we make astronauts provide geologists with as much knowledge as we possibly can? So the mission was to get geology and to get as the astronauts doing the best possible job they can, so they can compete with the best. So it wasn't really, in my mind, it wasn't leadership at all. It was how do we work for the mission? How do we work for the group? How do we work for the country? Because I was certainly working as hot as I can for the benefit of the United States of America. And how do you do that for the best of the program, the Apollo program? And people feel that, people know that. And the best reward I ever had was a statement from Apollo 15 astronaut Al Worden, when he was going around the moon for the very first time. And the minute we had him on the lead, so that on the microphone, so we could hear, he started talking about the fact that he sees that crater Tuskowski, and then before that, after such and such and such, and then he said, "My God!" After the King's training, because my nickname was King, I am looking at the moon, but I feel like I had been here before from the King's training. So that to me was was really the badge of the astronautship. Okay, but the impetus should be the success of the program. It's not the impetus so that I can become a minister. I got them the wazir or whatever it is, or get myself a better salary. The impetus should be from A to Z, the betterment of the program. What is it best for the program, for the Apollo program, and what's best for the geology, all of the training of the geology of the astronauts, and what is the value of the geological profession. That was the impetus, not for my doing better, or not from my making a better such and such, or not being a secretary of the committee, or not being a head of the group of NASA that was responsible for lunar exploration. There were 6, and they became the head of the division. But so it was not to become better or to have more salary or to be promoted. It was to work on the program and make absolutely certain that the program is the best. And one of the things that we used to say to each other constantly was, go ahead and do it right, and do it well. You don't want the Ruskies to beat us. You don't want the Russians to beat us, meaning it was really for the good of the program and the good of the country, from way down inside. Not so that you are promoted, not because you want to be better or to have a better chance. No, for the good of the program, for the best possible way that we can do this job. If we have a job, let's do it to the best of our ability, and all of us were working, and I'm here to do that, the best possible job which we can do for that job, because that job is great and it's good for everybody and for humanity. And my God, we're going to do it right, and we're going to do it the best of our ability. So that the impetus. This is the impetus. You don't work so that you can get promoted. You don't work to get more money, or you don't work to become a goddamn minister or whatever it is. You are working for the best possible place of that job, and of your profession and of your group you're within. Some of that is really part of my father's teaching. My father was a teacher in Al-Azhar, and he used to constantly say, and he spoke classical Arabic. He used to say, "Man ya'lam fa'alayhi an yu'allim an-nas wa illa fala naf'a fi ilmi." Meaning, if you know something, you should teach others, or else there is no benefit to your knowledge. If you learn something, you better tell the others, or else there is no benefit to your knowledge. So it's a very important item to say, okay, I'm a geologist, I read this and that, and I can look at satellite images, all right, and you can figure out. And if you can do that and say, here it is, and then publish in science and magazines and this and that, as I did all the time with all my students and this and that, and stop, there is really no real value to that knowledge, to Egyptians, to people in the desert, to Bedouins, to whoever. But if you can go and figure out that here is a bunch of people that learn or need that knowledge, and you can tell them that where water would accumulate because you learned something that they do not know, and you have the view from space that they cannot have, and you can tell them where to drill or get the government to drill for them where it would work out, then there is value to your knowledge. So whatever I learn, I either apply it or it doesn't work. As far as the GPS is concerned, it was not my invention, not at all. It was a group of engineers from the Goddard Space Flight Center, one of NASA's centers, not NASA headquarters, but NASA one NASA center in Greenbelt, Maryland. They got this idea, and they said, "My God, if we have something in space that can send notes or views or images or whatever to something that can receive it on Earth, we would know where that thing is exactly. because we can figure out that the location from the location that we know from space, we can learn the location of that thing on Earth. God damn, okay. So how do we test that? Well, we test it in either in both, in the top north and the North Pole and in the desert. So they did actually communicate with some guys, the Eskimos in the Northern Pole, and they said, tell them, we'll give you a thing to receive some note, just keep it with you while you're going and return it to us so that we can figure out when that machine received the thing that we sent from space. And then they came to me from the Smithsonian and said, hey, Farouk, you're going to go to the desert. We know that you're going to work in the desert in Egypt and so on. That's great, because we really need something from in North Africa specifically. So Egypt is perfect. So, and you're going to go to places. And I said, I don't know where I'm going. We have no good maps. They said, even better. You don't know where we'll get coordinates, exact coordinates of where you would rather be. I said, wonderful. So I took the machine from them and connected it to one of our Jeeps, and they told me that every day that we have some 6 to 8 times, you would have to stop that car. Where do you have them? Meaning your whole group of people or all cars to stop, and for 10 minutes, 5 minutes before the time, and after minutes to make sure that it is time when the spacecraft goes over you guys, because the spacecraft will be sending the thing, and then it will be received in this thing. And that thing, you will return it back to us, and then we'll figure it out. So we will tell you where you have been, so you would know exactly where you were, but after you return. And we did that. So that was the very beginnings of the test of the GPS. Yeah, I was already left my job at NASA headquarters, and I moved to the Smithsonian Institution to be part of the group that started the National Air and Space Museum after Apollo 16, the last mission, Apollo 17, after the last mission to the moon, ended in December 1972. I moved in January 1973 across the street from NASA headquarters to some place called the Smithsonian Institution in Washington to initiate the 3 years before we start the National Air and Space Museum, to plan the National Air and Space Museum. And one of the things that came to us was Graham Ferguson, one of the people that invented, one of the 3 people that invented this IMAX machine, got to NASA headquarters to tell them, I have a fantastic camera that can fly to space to do this and this and that. And they looked at it and said, they told them this is too big for us to carry in the spacecraft. And the guy that handles all of the photography for NASA anyway is a guy by the name of FaroukEl-Baz. He's across the street at NASA, at Smithsonian Institution. Go talk to him. So this Graham Ferguson came to me at my office and showed me the negative of the images, which was 70 millimeters, a huge negative like this, and showed me that this is the camera that does that kind of. And I looked at it. I said, "My God, it's fantastic quality." And we're going to have a movie theater in the Smithsonian. If we can take some images with this machine, it can be fantastic for the Air and Space Museum. It will be a step forward in movie making. So I went to my boss to tell him, hey, Mike, my boss was an astronaut, actually, Apollo 11 astronaut, Michael Collins. He was the director of the Air Space Museum. Then I said, Mike, that's such and such. And he said, Farouk, you gave us enough hell with cameras on the Apollo program. When even here, you're going to tell me another one? What would that cost? We're going to make a movie. I said, we can make the movie with this machine. He said, oh, tell me how much would this cost? We can make a movie with this machine. So I went to Ferguson and I said, listen, go home, figure out. We want a movie, no more than half an hour, just half an hour, 50 minutes, even 25 minutes is fine, but no more than half an hour, the movie that we're going to make. And we're going to call it To Fly and the History of Flight, from the first plane to other Apollo missions. We're going to make a movie using some kind of equipment. So if you use if we use this fantastic high resolution machine that you have, how much would it cost? So he told me. He went to calculated and this and that, and I said, be careful with the prices, because this might make you or break you. So he was careful with it and came back and told me $750,000. So I went back to Michael Collins and said, $750,000. He said, God damn, Farouk, we had $100,000 in our budget for this. 750,000. Well, I don't know what you have. I tell you what, we can go to the Secretary of the Smithsonian and see whether he would lend us this money, and we'll give it back to him, to them, to the headquarters. But let's see, that would be either he will give me that money or no more, or you can tell your friends no way. So he and I went to see the Secretary of the Smithsonian Institution, Dr. Dylan Ripley. He was an ornithologist, a bird man, whom I loved, and he knew me, and I had helped him in many ways. However, he was very good, and he sat down and listened to the whole thing. And he said, okay, how much would that cost? And Michael Collins looked at me. So I said, $750,000. So he said, okay, we can lend you this money as a loan. How long would it take you to pay it back? Mike Collins looked at me again. I said, 4 years, based on nothing. Just said 4 years. Just to give ourselves a little slack. Dylan Ripley looked at me and he said, well, 4 or 5 years is okay. So he gave us 1 more year to pay it back, which was really wonderful. So we went back delighted. So that same day I called Ferguson and I told him, God damn it, here it is. We can start the film To Fly. We're going to have your money, all of it, and just work on it now. Start it. So we did, and we opened that movie, and we made $2 million.
Wow.
A profit, pure profit, $2 million, pure profit. Because the thing is called To Fly. It was the most attended movie ever in the history of movie making, because millions and millions, the first year, 2 million people saw it. It was just unbelievable. So we called Ferguson to tell him that's okay. We got our money back, and we have $1,750,000 extra. So we got 2 million. So I told them we have 1,250,000 more. So you can make us a film about the Earth with that million and a quarter. And they made another movie, but that we had nothing to do with it. The movie To Fly were the ones that worked the story, and we had real historians to work it nicely and so on. But the second movie was a dud. Never really didn't work out. Anyway, this was the beginning of IMAX, because they were trying to sell it to anybody. Nobody was buying the idea, and we bought it from the Air and Space Museum through my connections, and that initiated the IMAX business. I'll tell you very, very briefly, the Mars story is a very interesting story, because Mars is very much like the Earth, and it lost much of its atmosphere. And look at whatever we're doing to the atmosphere today, question mark, where is that going to lead to? But Mars lost its atmosphere, but many of its features are identical to the features of the Earth and deserts. So the more we study the Earth, we learn more about Mars. The more we learn about Mars, the better we understand the Earth. So there is really a connection there. So I'm delighted that we're all studying Mars so well and so on. And as far as that thing that I was pointing to, so that I was really pointing him to a specific features, a valley on Mars, because that valley I recommended to the International Astronomical Union to name that feature on Mars by the name of Cairo. And they said, why in the hell? Cairo, why would not? I said, because Cairo was named after planet Mars. And they said, how is that? I said, well, when Jawhar Istiqlali invaded Egypt at the time of, and he started saying that we're going to have to build a new city near what's available now, or what's there, and we have, because the capital of Egypt then was called Fustat, and so we'll have to get an area near Fustat and we'll make a new city, because this is Fustat is old and miserable and so on. And so they said, okay, well, there is an area near Fustat that we can make a place for it. And they said, okay, start, put some rope, and this is where we're going to begin it. And bring in some scientists to select a name for the new city. Look at the man. It was an army boss, and he was going to build some new city before he called the Khalifa to come to Egypt to see it. But before he does that, he wants to name it, and he wants to name it correctly. So he said, bring the scientists to name the city. So the scientists came in and sat down, and they supposedly started praying, and there was a rope around the place where they were staying, and one bird came to the ghurab, landed on the rope, and there was a bell on the rope, and it rang, and some of them looked at where the sound came from, and the scientist that was a falaki, an astronomer, looked in the sky at that moment and looked, and he saw planet Mars rising in the sky. And he said, Al-Qahir fi Surud, Mars is rising, because in Arabic, the classical Arabic, the name of Mars, Al-Qahir, because Mars is the god of war to the Greeks, and they named the Mars after it, the god of war. And so the Arabs of the olden times called it Al-Qahir. So he said, Al-Qahir fi Surud, Allah takun Al-Qahira. Well, because Mars is rising, then let's call it Cairo, Al-Qahira. Al-Qahira, so that's the name, but the French came and they couldn't say Al-Qahira, so they said Le Caire, and then the Brits came after that, took that Le Caire and made it Cairo, and it became Cairo. But it was originally Al-Qahir, named after planet Mars.